Okay, everybody, let's go ahead and get started. So here at Solarc, we're a veteran-owned company. We're an engineering company, and we're dedicated to making folks less dependent on the power grid and doing that in a way that is affordable. In 7 years, or over 7 years of business, we actually haven't had a single customer return, and our flagship products, the Solarc 8K and the Solarc 12K, are currently the most efficient and affordable solar storage solutions in the world. So we have won several awards, as you can see here, the most recent of which is we're a semi-finalist in the American-Made Solar Prize for some of our work that's ongoing for working with utilities and a few other things. So with that, let's go ahead and jump in here. The agenda for today is we're going to be going through some recommended chemistries, the common chemistries, comparing the warranties and some of the characteristics thereof, some basic sizing with these chemistries, as well as a bunch of rules of thumb for common appliances on how many batteries you're going to need for common stuff. We're going to go through some solar sizing, so how many inverters you're going to need to support your battery bank and vice versa. Programming, we're going to do quite a bit on programming to make sure that you can use your batteries very effectively using Solarc. We're going to go through some frequently asked questions that we get in support, and then we're going to go over how to buy, and then we'll have Q&A at the end. All right, so jumping right in here, we've got the three most common chemistries used in solar today are lead acid, like the carbon-infused AGM type batteries, LFP, which is short for lithium iron phosphate. Most of you guys have probably heard of that one. And then we have your generic lithium ion category, which includes NMC, NCA, acronyms for other kinds of batteries. Usually the NCA and NMC are the mobile application type batteries. They tend to have a higher energy density, but they don't last quite as long. Stuff like Tesla batteries, think of car batteries, that kind of thing. LFP, they're a little bit bigger, a little less energy dense, but they're a lot safer, and they last a lot longer. And then back over to the lead acid AGMs. Lead acid's been around for a very long time, but the carbon addition to the lead acid AGM is a relatively new addition to the repertoire of lead acid batteries, and it has significantly improved their performance. So I'll just go through a few of the key specs here. They're all pretty much the same efficiency, which is pretty cool. So you're not losing a whole lot of energy inside the battery these days. The cost per kilowatt hour is pretty similar on the lithium front. It's a lot cheaper per kilowatt hour for lead acid, but they don't last for nearly as many cycles. So we'll see here at the bottom of the chart how the math kind of works out. Their off-grid cycle counts, as you can see here, LFP is going to last the longest by a pretty wide margin, especially in off-grid situations. And then back down to that cost per kilowatt hour here, you can see that most of the time the lead acid is actually going to be the cheapest per kilowatt hour that you put through the battery. But given that LFP is so much more longer, it lives so much longer, a lot of cases it makes more sense to go with LFP. So the general rule of thumb here for this is that lead acid AGMs are still the best bet for long-term outage or infrequent outages. So if you're just trying to protect against an outage every once in a while and you're not really using the batteries on a daily basis, AGM still makes the most sense there with the carbon AGMs. If you're going to be using the batteries daily and doing deeper discharging, LFP is going to be the best case for most situations. And then the NMC category, it doesn't really make a whole lot of sense most of the time for any kind of solar application. So a few of the drawbacks of each of these chemistries. For lead acid, you can, in theory, over-discharge these batteries because they don't have a management system. I haven't seen a management system on a lead acid battery ever. So usually the inverter, though, will take care of this problem and prevent over-discharging. The Solarc certainly does that for your lead acid batteries. The other thing is that heat does reduce the lifespan over a long period of time. So if you keep your lead acid batteries too warm over long periods of time, they will degrade a little bit. And then on the lithium side, they do actually need a battery management system, or BMS for short, to make sure that all the cells are at the same voltages and stuff is safe, which does mean that sometimes you have some BMS reliability issues depending on the brand that you go with. And they also don't like getting cold. They don't like to be used if it's below 0 Celsius or freezing. So you always want to look into the warranties on these kind of batteries. There's a lot of times, like in some cases, your warranty is going to be cut in half if it's charged, or usually if it's charged below freezing, if the battery doesn't have some kind of onboard internal heater. But all right, let's go ahead and move on. So for BMS is required for balancing cells. LFP, you definitely are going to want to go with a battery management system. And for NMC and NCA, you pretty much should be using one also. It's highly recommended for pretty much any kind of lithium battery. And they help protect from overcharging, discharging, shorts, thermal runaway, that kind of stuff. And the Sol-Ark and inverters can actually do their part to help out with some settings to make sure that the battery is treated appropriately to help the BMS out as well. Battery management systems are really good for measuring state of charge, battery temperature, and occasionally you can get some that are capable of communicating with the inverter that they're connected to, which is pretty cool. A little bit more information here. There's two main categories of battery management systems. There's active or MOSFET-based, and there's passive or relay-based systems out there. So the MOSFETs, they're a little bit more finicky. They're susceptible to ESD damage, and larger inverters such as the Sol-Ark have a lot of capacitance. And when you first connect the battery for the first time, there's a pretty large surge, and not all BMSs, these are MOSFET-based BMSs are cut out for that, so it's something to look into. Not all of them are bad. There are a few good ones out there, but just be careful with that category. And then with the passive ones, they're actually pretty robust. They're just more expensive, but they are more reliable. And then if you're going to be shopping for a BMS, a few things to note are you're going to want to look at their continuous amps, surge, peak, amperage, free charging, ESD, and all that, everything listed here. You need to make sure that it's capable of being discharged at the rate that the inverter and the loads are going to require. Also, you want to make sure that it's capable of supporting whatever the peak power is on the inverter. For example, for each Sol-Ark 12K, you're going to want to look for a rating of probably around at least 500 amps for 5 to 10 seconds to support the 20 kW peak power for 10 seconds on a Sol-Ark 12K, just as an example. Also, highly accelerated life testing is a really good way to make sure that the quality is there. So that's always something to look for. The Sol-Ark 12K, actually, we did halt testing on as well, but it's also really good to look for that on your BMS. So, quick example on some of the stuff that happens in lithium battery warranties. It is LG Chem, I actually applaud them for being so transparent about this, but it's just good to know. This is, if you look here on the left, you can see that once you get down to year 7, you're only going to get 6% of the of the value purchase price back from the warranty, and it drops off a cliff really quickly. So if it fails early on, yeah, you're pretty much covered, but it drops off a cliff, and that's something that's really important to note. Because yes, it does have a 10-year warranty, but if it fails later in life, you're really not getting much out of that warranty. Also, the temperature does affect the warranty. Like I mentioned before, you got to keep it within their operating temperature range, and the capacity of the battery actually decreases over time. So at 10 years, you can expect to only have 60% of your capacity, and realistically, all this combined, they're really only going to cover you for 6 or 7 years, reasonably. Also, a quick note just on this particular kind of battery. It's one of these batteries that's got a higher voltage externally, 380 volts external voltage, but it's still 50 volts internally, which means that it's stepping down and then stepping back up the voltage, which leads to a fair amount of losses inside the battery. So just something to note here. In this example, this LG Chem loses about 11% just inside the battery. So not even including the inverter. But with that, let's go ahead and move on to how big of a battery you need. So this slide I'm going to kind of go over pretty quickly. I don't want to get into the nitty-gritty too much, but if you want to do it the hard way or the right way, I guess, you go through and you would go through the house for your customer or the application, whatever the building is, the application is, and you go through each circuit and you calculate exactly what the continuous demand is and the peak demand is for each circuit. You add all that up, and eventually you get your answer and how big of a battery you need. But there's a bunch of rules of thumb that make this a lot easier. So let's go ahead and jump into that. So here I have a bunch of appliances, common appliances, and I have an amp hour rating at 48 volts for each of these. So what this means is if you have 1 ton of AC, you tend to need about 150 amp hours of battery to support that 1 ton of AC. So if you had 2 tons, you need 300 and so on. That's kind of how to use these recommended values here. So as you can see, air conditioning is huge. Refrigerators, not that bad. Freezers, really not that bad. Well pumps, they don't need a whole lot for their continuous demand, but something to take note of for the well pumps is that they are what's called an inductive load. So they have a pretty high peak power demand when they first turn on. So for example, one Solarc 12K or 8K is capable of dealing with about 3 horsepower of startup. So just bear that in mind whenever you're doing any kind of inductive loads like that. So pumps, air conditioning, so on. And then another quick thing here is lights and TVs, computers, that kind of stuff, cell phone chargers, they're pretty much negligible. If you size your system appropriately for all the larger stuff in the project, you don't really need to worry about these so much because they'll be covered just because of how small they are. A few more things here, microwave, washing machine, coffee pot, all that good stuff. Just some good rules of thumb here. And then, of course, when in doubt, if you have like a residential application and your customer just wants to know, hey, if I only want to back up my critical stuff, I don't want to do the AC, I don't want to do anything like that. I just want to cover my refrigeration, lights, computers, and those kind of things. 400 amp hours of carbon AGMs or about 200 amp hours of lithium will be just fine for most applications where they don't want to do the really big stuff off-grid. That's just a good rule of thumb. If you have to kind of give a quick off-the-cuff quote or something to the customer, that's a good way to do that. And then if you're off-grid, if you have a customer that's either off-grid from the get-go or planning on being off-grid for long periods of time, the bigger the battery, the better. We highly recommend you oversize as much as you can within reason if you're going to be off-grid. Just makes everything better, bigger leniency and all that good stuff. So here are some specs for how big of a battery you need to make the most of a Solarc 12K or 8K inverter. So the minimum battery size to get the maximum continuous output from the inverter whenever you're only going off of battery is going to be about 200 amp hours of lithium, as long as you can discharge at 1C. And 1C refers to the capacity of the battery bank. So 1C of a 200 amp hour battery is going to be 200 amps of continuous discharge. But not all batteries can do that, or BMSs can do that. So another example is if you had a 0.5C, or half the capacity of the battery's discharge rate, then 400 amp hours will get you the most out of the system. And then a couple of quick ones down here. The minimum battery for operating off-grid is about 50 amp hours for the Solarc. Now, I do not recommend that you only get 50 amp hours of battery, and it's not going to perform super great if you try to use that battery. But the Solarc will act as if it has a battery if you have 50 amps or more. And then the maximum size battery is pretty much as big as you want it to be, but the programming inside the system is only going to keep track of the capacity of the battery bank if it's 9,900 amp hours or less, which is huge. So usually that's not an issue. So when you're connecting your batteries to the Solarc, if you have parallel Solarcs, you need to have one big battery bank, and then each inverter gets its own connection to said large battery bank. And then you also need to make sure that your connections between groups of batteries in your battery bank are sized appropriately. So they need to be able to handle the current of all the systems connected, which means that normally once you get up to 2, 3, 4, etc. systems, you pretty much have to use bus bars to have the current ratings required. And then a couple other things here is how far can you put the batteries from the system? And the usual answer is about 10 feet if you use 2-aught copper wire. If you buy the wire from us directly, we're going to give you a 6-foot stretch of 2-aught copper wire. That's the pretty standard length that we do. But you can go up to 10 feet with 2-aught and up to 25 feet with 4-aught. Anything further than that's pretty rough for the 48-volt battery bank. So, you know, it is what it is if you have to, but make sure you do the math on that. And then a quick note is just whenever you're putting batteries together, be very careful to make sure that all your battery lugs are tight. It'll save you a lot of headaches in the future and improve the lifespan of the battery. So now we're going to get into some programming. Here you can see the battery setup screen and the battery tab of the battery setup screen. And I'm just going to go through what each of these things mean really quick. Battery capacity, that's just going to be the amp hours of your battery bank. Max amp charge and max amp discharge are exactly what they sound like. It's going to limit how much power we pull out of or put into your battery bank, which is important for its longevity. And then there's the temperature coefficient here. We use that mostly for AGM batteries, lead-acid batteries. So -5 is the default value, and that's perfectly fine for a lead-acid battery. But if you're using lithium, make sure that you change that to 0. Because we don't need to adjust for the temperature for a lithium battery. And then on the right side of this screen, we've got percentage versus voltage. That just means how the inverter is going to interpret your settings. So we can display your battery's state of charge as a percentage, or we can just give you the voltage based off your preference. The Sol-Ark does work without batteries, and if you're doing an install, either before you do the install with batteries, you want to just get it up and running for a little bit, or the customer just wants to use it as a grid-tied system, make sure that you select no battery. Otherwise, the system's going to beep at you. And then BMS lithium battery, that is, you only check that if you have a battery that's compatible to communicate with the Sol-Ark. So stuff like Discover, Fortress, Blue Ion, some of those batteries and a bunch more are working with us right now to become compatible. But if you do have one that's compatible and it's connected that way, go ahead and use that checkbox. And a quick note on that, if you have a lithium battery with a BMS that doesn't communicate with us or isn't compatible yet, no worries. We have a really good state of charge calculation built into the Sol-Ark. It's a proprietary self-learning algorithm, and it does a really good job by itself, even without communication. And then lastly here we have Activate Battery. This basically just applies a little bit of voltage to the battery every once in a while to make sure that it doesn't fall asleep if you have a BMS. So obviously you don't need to use this if you have no battery selected, so make sure that you don't have both of those selected at the same time just to make sure that you don't get any errors. All right, next up. So the first few settings here are pretty much going to be from your battery manufacturer. So float and absorb, I think most folks are going to be familiar with. You're going to get that from your manufacturer on how to charge the battery. Equalization is a bit interesting usually for folks. Yes, you don't technically need to equalize a lithium battery, but we still use the function called equalize for lithium batteries usually. We just set the voltage equal to the absorb and just set the time to like an hour. So just to make sure that the battery is all the way full every once in a while, every 30 days or so. Now, if you do adamantly not want to use this feature at all, just change the hours to 0, and it will never use the equalize function at all. So, all right, moving on to this little checkbox here on the left. Start voltage or start percentage. You're only going to be able to use one either percent or voltage at a time, depending on which mode you put the inverter in. And basically this is referring to when we're going to call for a generator. We have a 2-wire start built in to the Solarc. So if you, in this case, this example, if you hit 30% state of charge, then we're going to close that relay and we're going to call for a generator to come in and help charge. Then we have the amp setting here, and this is going to be where you select how many amps to the battery at the battery's voltage you want to charge at given the power source. So in this case, we have 60 amps if it's coming from the grid, or 40 amps if it's coming from a generator. And the reason you can select differently for that is a lot of times if you have a smaller generator, you want to make sure that you don't overload that generator, so you would adjust your charging rate accordingly. And then from the grid, a lot of times you'll have that less than the value that you would charge from your solar panels, just because why not? It's usually easier on batteries to charge slowly as opposed to super quickly, and if you usually have time with the grid. And lastly, here these little checkboxes are to enable each column's settings. So here I only have grid charge selected. That's why these are editable here on the right, not grayed out. If I had gen charge selected as well, then I'd have percent and amps with a white background also. All right. So battery communications. This is an example of the information that we can get from a battery's BMS. So stuff like charge voltage, max charge amps, max discharge amps, temperature, state of charge, and these are all dynamic values. So we're getting these from the BMS basically in real time, which is cool. And the battery can basically tell the Solarc to change its own settings also in real time. So here, for example, we have the BMS lithium battery selected because we have a BMS that's trying to talk to us, and it's also a lithium battery, so we've changed this to 0 millivolts per degree C per cell, and so on. And the battery is actually capable of changing the float, absorb, and all that stuff as well, so that's pretty cool. Now, like I said, Discover Blue Ion Fortress should be coming here in May 2020, so that's pretty sweet. Here we go with some more settings. The discharge tab. So your shutdown voltage or percentage, this is just when the inverter stops putting out AC power to protect the battery. Low battery it doesn't really do a whole lot. It just makes the battery icon on the home screen turn yellow to give the user a warning that, hey, your battery's getting kind of low. And then restart is whenever we'll resume AC output. So if you were to drain the battery all the way to 20%, the inverter would shut down, recharge off the solar panels until it hit 50%, and then it would resume powering loads on the AC side. Battery resistance is just going to be the resistance of your battery bank. We have some example values of these in our manual. You can also measure it, or you can get it from your manufacturer. But 25 milliohms is pretty good for most cases. So usually, when in doubt, you can just leave it as the default. We use this for calculating the allowable voltage drop under a load. So if you have like thresholds set for a particular voltage for time of use settings or something, it will adjust that value based off of how many amps are coming in or out of the battery, just so that everything is more accurate. And then battery charging efficiency, as I was saying before, pretty much all the batteries being used right now in solar are 99%, so you won't usually have to change that setting unless you're using like a wet cell battery or something. And then arguably the most important thing on this screen is going to be the battery empty voltage. We use this for a few different things. One is to prevent damage to the inverter and the battery when you're off-grid. So if you're discharging your battery bank and you hit this voltage, we're going to turn the inverter off before the BMS turns itself off, because you don't want to. It's not really good to disconnect the battery from the inverter whenever it's under heavy load. So it saves both parties there. But it also this empty voltage also determines the floor for our state of charge calculations. So if the system thinks you're at 20%, but then you hit the battery empty voltage, we're going to redefine that voltage. We're going to redefine how much energy was taken out of the battery to be the full battery's capacity, and this helps us get the SOC more and more accurate over time with our learning algorithm. And then the default value here, just so you guys know, is 47 volts. and that's a pretty good value for lead-acid batteries. You're going to want to change that depending on what kind of battery you have. And again, we have some examples of what the value needs to be in the manual for a few different brands of batteries. Usually lithium is more like 50 or 51 volts for this value, so just make sure that you're setting that appropriately. And all right, so now we're on to your kind of time of use settings here, grid charge, gen charge, all that good stuff. So the prioritization of where the power is coming from is going to be solar panels always are going to go first for the battery charging. The grid's always next priority, and then generator is your third priority. And a quick note on the generator charging setup is that if we call for a generator to charge the battery back up, we will continue to charge the battery using the generator until the battery accepts equal to or less than 5% of the amp hours for the battery bank. And I know it's a bit of a mouthful, but basically, if you had a 100 amp hour battery, we would keep charging that battery from the generator until the battery accepted 5 amps or less. That's how we determine when it's close enough to full that we should turn the generator off. And also, if you're using a generator and time of use at the same time, please note that the time of use settings do have an effect on generator charging. Namely, this column on the right here with a bunch of checkboxes for a generator. If you do not have a checkbox in the current time slot, whenever the generator is called for, we won't call for the generator. And basically, the reason for this is you can have quiet time for the client. So if they don't want the generator to, if it's noisy or something, it's by the bedroom or what have you, you can have slots where the generator just won't be called for. Or you can use it to stagger how long the generator can run for, and a few other things like that. But just be aware of that whenever you're setting up time of use with a generator. A few more things to note here is if you are using a generator when it's connected to the Solarc's grid input breaker, you need to select this box here in cell control called Gen Connect to Grid Input. That's to tell the inverter to expect a generator so that we don't try to sell back to it. Because as you guys probably know, there can only be one winner in that situation, and we prefer not to get into that. Also, to improve the generator connectivity, because a lot of generators tend to have, let's say, not the cleanest power usually. So we recommend that you change the inverter settings to general standard mode, which is over here in cell control, and then also going over to your grid input tab and widening the range of frequencies that are acceptable for the Solarc before it disconnects. So usually you can do 55 to 65 hertz instead of the default values, and that'll improve the connectivity to a generator. All right, and then some other things we can do with generators and the grid is we can do peak shaving or Gen Assist. And so peak shaving is pretty straightforward. You're going to use that for customers that have like demand charges. You can set a threshold value, and the Solarc will step in with the battery power to keep the properties, power usage below whatever your threshold is. So kind of like this chart on the left here, the red line is what you would have been using, and the green line is the threshold, and then the blue is what you actually wound up using with the setting enabled. So you're going to save a lot of money for your customer there if they're getting billed that way. Quick note too, if you're doing grid peak shaving, you are going to need to install the current transformers for that. The Solarc ships with current transformers already in the box that are rated for 2-watt wire. If you know that your install is going to require larger CPs because you got like a 4-watt wire for the main service panel or something like that, please let us know whenever you order, and we can get those to you. I think they're like $80 or something like that. Just make sure to let us know. Okay, so as for generator, Gen Assist, you can, same thing as grid shaving, but it's really useful for smaller generators. So you can set your threshold value to protect the generator. So if you're charging off the generator and it's only like in this case, like maybe it's a 8,000 or 9,000 watt generator, you'll want to set the threshold value for 1,000 or 2,000 watts below whatever the generator's maximum output is rated for. And then the batteries will start discharging instead of charging if the generator hits that value. And that's a good way to be able to pass the AC power through the system to your loads and charge without overloading an undersized generator connected to the solar. Okay. So time of use and grid cell. These examples here are with a lithium battery. And I'll just go through this real quick here to explain what each of these columns mean so that you get your time of use settings correct. You've got your time, you've got power, which is specifically how much power you take out of only the battery. This value doesn't affect your PV production. And then the percentage, if you're in percentage mode. If you're in voltage mode, it'll show a voltage here. But in this case, it'll sell up to 2,000 watts from 1 a.m. to 5 a.m. in order to offset the home's usage until the battery hits 40%, and so on. And since lithium batteries, you can pretty much have the setting the same all day long, is the recommendation. The same thing for every time slot throughout the day. So you're in grid cell, limited to home, and time of use. So during the day, you'll sell excess PV power to the grid, and then at night, you'll only sell to offset the house's power usage from the batteries, and so on. And a quick note here is that these percentages on the right, these are just the minimum allowable SOCs. If you have solar power, the system's always going to try and keep the battery as full as possible, given the situation. But if you're not using that much power in the house, or you have enough solar to offset the whole home usage, it will charge up the battery bank as well. And then over here on 2,000 watts from the battery, 0 the home meter, and batteries will discharge to a maximum of 40%. Okay, yep. Moving on, we've got smart load. So smart load is a cool feature. It's basically automatic load shedding. So we have inside the Solarc 8K and the 12K, there are 3 breakers on the right. You've got the loads that go to the load breaker that just goes to your backup loads. Grid is the grid input or generator input sometimes. And then the gen breaker is basically a Swiss Army knife breaker. We can program that to do quite a few things. And one of those things is smart load output. So we can only turn on the smart loads given you're making enough power on the solar panels or you have enough SOC on the battery bank. So in this case, up in the right-hand corner here, we won't turn on the smart load unless the batteries are at least 90% full and we're making 500 watts on the solar panels. And this is really useful for off-grid situations and for air conditioning. Water heaters are the most common appliances for this. And what it ends up doing is it reduces the battery bank size somewhere between 10 and 40% for off-grid installs, because you're only going to be powering those larger power-hungry devices during the day when the solar panels can help out, which is a pretty sweet feature there. And a quick note, if you don't want the solar panels to be taken into account for when the smart load comes on, you can change the solar panel wattage to 0, and then it'll be entirely SOC based. And then just real quick, the off value here is whenever we would stop powering the smart load. So in this example, if the batteries got down to 80%, we would basically kill power to the gen breaker and conserve our battery for the more critical stuff on the load panel. Also, if you use the smart load, or I guess I should say if you use AC coupling, you're going to use up the generator breaker, whether or not you put it on the load panel for load side AC coupling or the generator for gen side AC coupling. Either way, it uses up the port. So you can't have something AC coupled to the load panel and still use smart load. So there's a little bit of a trade-off there, but you do have, at least you have options, right? Okay, let's get into some frequently asked questions. So a lot of times folks will start out with a smaller battery bank than they really needed, because batteries can be a fairly substantial chunk of the cost of an install. So they want to know how long they have to add more batteries. And it kind of depends on the chemistry, or it really does. So for lead acid, you have about a year to add some more batteries without it being too detrimental. And for lithium, as long as it has a BMS, you can pretty much add one whenever, because the BMS will handle the differences between the cells hooked up in parallel. And then as far as mixing chemistries, technically you can. For example, you could have some lithium batteries and some lead acid batteries all in one bank, and that's okay for a short period of time if you need to do that, but typically we don't recommend doing that for a long time because the effects can be detrimental to both batteries involved, or both battery banks involved. Also, a quick note on the temperature sensor placement. Usually what we'll do, or we recommend doing, is you just tape that to the inside or in between a few batteries in the battery bank, and that gets a good contact with the thermal mass of the batteries. And whenever you're hooking the battery sensor up to the Sol-Ark, it goes in pins 1 and 2. And don't worry, we have diagrams in the manual for finding that. It's also labeled on the circuit board, but there's no polarity on that, so don't worry about the red and the white wires. Just go ahead and stick it in there. And then, of course, if you have a BMS that does have communication protocol with the Sol-Ark, we're going to go ahead and get the temperature from the BMS anyways, so not super important to hook up the one that comes in the box in that case. So as far as where to go to get more information, I highly recommend checking out solark.com/support. We have tons of documents, manuals, etc. There. Our YouTube channel is very informative. We have a lot of videos, recorded webinars, etc. that go through a bunch of information about our products, as well as some training material. And then, feel free to give us a call anytime. We're always here to help. You can call if it's a technical question. Dial this number down here and dial extension number 2 to get support. And if it's a sales-related question, go ahead and dial extension number 1. And they're happy to help you out. So some of the benefits of being a Sol-Ark customer, we do have support 7 days a week. So we're doing that as a big thank you to our customer base. We're trying to help you guys out. So feel free to give us a call if you're having troubles. We do have very fast delivery times as well. Our lead times are pretty short at 7 to 10 business days, sometimes even faster if you get lucky. And we have a very flexible network. So we're always adding new distributors, and we're accepting more. In fact, I believe this next slide, yep. So if you'd like to join our network, you can go ahead and go to our website, and this little snapshot down here in the bottom right, there's a sign-up button. You can click on that and apply to be one of our partners. As you can see here, we have quite a few already. So the blue pins are distributors, and the yellow-orange pins are installers. So that's where you can get Sol-Ark, and if you'd like to show up on this map, go ahead and sign up and apply to join up. And of course, given the current global climate, are we still open? Yes, we are. We're fully operational. In fact, we're adding to production and inventory capacity. Also, keep an eye out. We are planning on doing webinars every Friday at 12 p.m. Eastern, 11 a.m. Central Standard Time. So something to look out for there.